Kia ora, it's whānau. Welcome to video 3 of our Pico series. This is our Pico here. You'll see I've swapped mine for one with some header pins soldered on. I have down here as well this wonderful breadboard. I have here as well this jumper cable they're called, and this standard 1.4 volt LED. Okay. Our goal today is to take what we've done on the onboard LED and then turn it into an offboard LED so we can actually start to build a circuit. First thing I want you to do is I want you to take a look at the soldering on your header pins. Some of these may have been done professionally, some of them may have been done just by people learning. So what I want you to do is I want you to check that there aren't any holes between the pin and the board, and that there's no solder connecting up any of those two pins. If there are, you may just need to just double check that it's soldered correctly and that maybe have a re-solder on it to make sure that we don't have any bugs that way. Debugging circuits is hard. Let's try to get ahead of problems before they happen. So, first thing that we're going to do is we are going to take our Pico and we're going to put it in the breadboard. I've just lined it up, as you can see there, just so it's one pin per hole, and I'm starting right from row 1. I'm just going to pop that in there, and look, that's so satisfying. In it goes. A little bit trickier to get them out, but in just fine. Okay. We have our LED here, and what we're trying to do is we're trying to make, let's see if I can pull it up. We're trying to make this circuit. A couple of things we need to cover. First of all, what on earth is this breadboard? What is it doing? Why do we have it? Okay, the issue is if I'm trying to connect up this LED to this Pico here with no headers, when I stick it in the holes, there's always just going to be tiny gaps, and I'm never going to get a good connection. It's just impossible. So what we do is we put a little solder on those wires. I can't solder on the LED, then I'll only ever be able to make one circuit. So I solder on those header pins, and I put it in a breadboard so we can prototype our circuits straight away and connect them much easier. Okay, so what a breadboard is, let's see if I can bring it up just to show you the camera, it is just rows of wires that run this way and rows of wires that run that way. This side and that side are not connected. And then it is rows of wire that run that way, one wire that runs there, one wire that runs there. They are not connected that way. One wire that runs that way, and one wire that runs this way. If I plug into any of these outer squares, I'm connected. If I plug into any of those, I'm connected. Now, it's traditional, it's standard to turn this side, you'll see the blue, into negative. What does that mean? My ground. Once I'm finished doing anything interesting with my components, I send it to ground, to negative. And this one to positive, to high, where the power is coming in from. So in order to make my circuit, what's a circuit? It needs to be a complete loop. A bicycle circuit, it's complete. It's a complete loop. If it's not a complete loop, you don't have a circuit, you're going to have a bad time. And so all the interesting stuff here happens in the middle. I've done something a little bit silly in that all of these pins, I've only left myself with one square here to connect to, and I've left myself with 3 on that side. So I might see if I can just shift it. Maybe if I can, maybe that's a bit tricky today. Maybe I'll shift it between videos rather than on camera. Okay. Cool. Okay. Next step, what we want to do is we want to put in our LED, and we're going to just put our LED across these two here. Now you'll see that one leg on the LED is shorter than the other. That's because it's directional. It's a diode. It will not let current through. So what we're going to do is we're just going to kick out that little that little short end, that little long end, and just so that we can know which way is which. And I'm just going to connect it to, you know, any of those squares and try to do it in such a way where you can see me doing it. Whoa, and we've done a proper on those legs. Okay, cool. Anyway, my LED is in there, very, very wonky. Okay, cool. I'll just shift it so it's nice and even. There we go, in row 25. I'm now going to connect up, like the diagram says, row 25 to ground. And there we go, that's it, nice and easy. I'm going to connect up ground to one of these along here. But which one? I can follow the diagram and I can see that it is pin 3 along here. 1, 2, 3. But how do I know that? How do I know for sure? Well, for that we can check a schematic. A schematic, a diagram. Look at this. Okay, this is a pin out diagram, and I'll get rid of my Raspberry Pi. I'll get rid of the Pico. There we go. Okay, this is a pin out diagram. We're going to be coming back to this time and time and time again. What does this mean? What are all these colors? What is actually very, very complicated? Yes, the Pico, despite its size, is a complicated device. It is a working computer. And it has lots of things that you can do with it, and lots of different types of inputs and outputs that it has on here. What we're really interested in at the moment are these GND, GND for ground. We could be using any of those today. The diagram we're looking at has chosen up there pin 38. So we start at the top and we go all the way from 1, loop down to 20 and across to 21 and up to 40 pins in total on the Raspberry Pi Pico. We're going to stick it into 38 to connect up to ground. The other thing I should mention before we go away from this screen is we need an output pin. We need a pin, an output on the Pico that says, hey, turn the LED on or turn the LED off. And for that, we're going to be using pin 20, but it's not going to be called pin 20, it's going to be called 15. Why? Because it is this one here. It's 20th slot, but it is actually GP15. What is that? GPIO. GPIO, general purpose input or output. Look at that. You can see that on the key over here. GPIO, general purpose input and output. And turning an LED on and off, that's a general purpose. So, back to our Pico. See if I can bring him back. I might just change screens because that's very noisy. That's still very noisy. Let's go here. Much better. Still noisy. Why? Where's a white screen when you need it? Okay. We have our wire, which is currently connected to ground, to this row of the breadboard. We're going to connect it to pin 38. So I'm going to come across here and I'm just going to count 1, 2, 3. In it goes anywhere along that line. Hey presto, we have a connection. Hopefully. These breadboards can be a bit dodgy, so we do need to test that our connections are strong regularly. Okay, lucky last. Where's our diagram? Not that one, this one. Okay, so we need one more thing. We need to connect up that leg to that leg. That is pin 15, pin 20 GPIO 15, from there to that row to our LED. Now, how have they done it? They've done it with a resistor. Are we going to use a resistor today? We can just use a jumper wire, right? No, you cannot. Why not? Because you will burn out this LED and you won't even know. It'll just stop working. It's not like it burns and there's smoke or there's a little bit of fire. It just stops working, and then your circuit doesn't work and you wonder, why is my circuit not working? Is it a connection? Is it my code? You spend half an hour on it, an hour trying to debug your circuit. It turns out it was just a blown LED the whole time, and a blown LED looks identical to a working one, except it just doesn't work. Very, very frustrating. So we're not going to pop any LEDs for the next person. Okay, what resistor? What resistor are we going to use? Good question. Great question. And for that, we need Ohm's Law and a little bit of math. Okay, so we know that the Pico is going to be putting out 5 volts. It's going to be putting out 5 volts, fairly standard for a USB connection to be putting out 5 volts. 5 volts is coming in. What is voltage? It's the punch. It's the energy that the electricity has. All right. We also have current, which is the big question mark. We know this LED is rated for 20 milliamps. So that's its maximum. We don't want to hit its maximum. We want to hit 10 milliamps. Small m, capital A. So what resistor do we use? This is voltage. This is current. Current is the amount of electricity that's flowing. Literally, how many electrons are flowing in the wires per second. And then we have resistance, which is a big question mark at the moment. And what is the resistance? Resistance is the friction. It slows down the current. It uses up the voltage. It uses up the energy. It eats the voltage so that it can't be used up by the LED and burn it up. Okay. Here is one of the most important equations in electronics. And it goes like this. V equals I R. V equals IR. That's it. Nice, easy, simple. The voltage is equal to the current times the resistance. Okay, that's great. So what resistor do I use? Doesn't really help, does it? Okay, well, let's rearrange this a little bit. Let's put it in a little fancy triangle. So if I put voltage up here, and I put, let's draw it myself. Oh, not so nice a triangle. A little triangle here. And I say V equals I, and I put R over here. Oh, look at this nice little thing. Cool. What I can do is, if I want the resistance, I can just cover that up with my finger. And now I know that it's the voltage divided by the current. Hey, look at that. Hey, thank you, fancy triangle. So my resistance, what I need is going to be the voltage divided by the current. Fantastic. Isn't that great? The voltage. What's the voltage again? The voltage is 5 volts, is it? No, the voltage is not 5 volts because my LED is already going to be using up 1.4 of those volts. So my LED, 1.4 volts is my LED voltage. 1.4 volts goes to my LED. Everything else goes to my resistor. So how much is 5 minus 1.4 less 3.6? 3.6 volts is my resistor voltage. And the thing I want to know is the resistance of my resistor. So I'm going to say my resistance is going to equal 3.6 volts. Divided by 10 milliamps. It's the same current everywhere. $10 milliamps. So, like, clearly it's 0.36, right? No. Haha. Another trick. Okay. We're in milliamps, so we've got to get rid of that, which, so that's actually 3.6 divided by 0.01. Dividing by a decimal is the same as multiplying. We should be all fine with this now. And so that, it's 360 ohms. 360 ohms. Ohms, that's the first time you've used that word. What's that? It's the unit of resistance. Volts is in volts. Current is in amps. Resistance is in ohms. That's all. It could have had any other name. It has just the name ohms. Great. So we go to our packet of resistors, and we look through it for a, okay, there's a lot in here. We look through for a roundabout 360. I have here a packet of 330. A 330 ohm resistor. So we're going to be a little under resisted. We're going to get our current a little above 10 milliamps, but remember, as long as it's not above 20 milliamps, we are fine. Just jumping off screen to grab myself a pair of scissors. Let's go. Oh, let's do it on camera. Why not? Okay. Get my resistor into pin 20. In it goes. These are not directional, so you do not need to worry about where you do it. Okay. Are we good? Are we ready? Let's jump back over to Thonny and let's run it. Whoop. Bit more onto screen. What are the chances that I have the LED backwards? That's not even my issue. What's my issue? I'm still using the onboard LED. I don't want the LED, the onboard LED. I want pin 15. So I only need to change one thing. Unless I change the pattern that I want to blink, which we will soon, but right now we're just going to leave that the same. I just want to get pin 15. Remember, it's in slot 20, but it's pin 15 for the GPIO. Here we go. Hey, there we go. That's it. We now have a circuit on a breadboard. We now have the ability to control something outside of our Raspberry Pi Pico. And from here, the world's our oyster. We can find other outputs, other sensors. We're going to run some motors. We're going to do all sorts. But this is the humble beginnings. Okay? All of this absolutely essential to understand, that we do need that resistor, how to figure out what that resistor is, and also what the layout of our Raspberry Pi Pico is. Its schematic, its pin diagram, and also to double check the soldering and the wiring and how to use the breadboard. That's a lot. Ka pai tō mahi. Well done. I hope you got that far. We'll see you on the next one.